In the last video, I showed you how to determine the zeros and multiplicity from a function that was in factored form. Now what we're going to do in this video is I'm going to give you some zeros and multiplicity, and you need to write the function. Okay? So for example number 5, we want to write an example of a function with the zeros of 2, -4, and 7, and each with multiplicity of 1. So that means I'm only going to have 3 factors here. I have 3 little zeros, so I want 3 factors. Now you can write f of x or y. Because it's asking for a function, I would suggest you write f of x. Okay, so f of x is equal to, I need some functions here. I need some little factors here. So the first factor needs to give me a 0 of +2. So in factored form, that means I would have x minus 2. My next 0 is -4, so I need a factor that would give me a -4, so that would be x plus 4. And then I have factor or 0 of 7, so a factor of x minus 7 would give me a +7. Now, the multiplicity of 1 means I want each of these factors to show up one time. And so this would give me my +2, this would give me my -4, this would give me my +7, and I have just written an example of a function with those zeros. There is nothing in this problem that says you need to multiply it out, so don't do it. It's extra work that you don't need to do. All right. So example number 6, I want you to write an example of a function with zeros of 5, -7, and 12, each with multiplicity of 2. So each one of these has to show up twice. So let's figure it out. Let's do f of x, g of x, h of x, pick your function form. All right, my first 0 is 5. So if I want a +5, that means I need a factor of x minus 5. Then I want the value -7 as a 0, so x plus 7. Right, you'll notice I keep changing the signs on these. And then my last factor needs to get me a 0 of 12. So x minus 12. Now, because I want each one of these to have multiplicity of 2, I am going to make each of these factors raise it to the second power. And again, I'm done. All right, don't make this more complicated. Absolutely do not multiply this out. All right, there is no reason to. There's nothing in the directions that tell you to, so don't bother. All right, don't do it. All right, so it says for problem number 7 here, example 7, write an example of a function with 0 of 2, in parentheses, multiplicity of 1, and -4, multiplicity of 3. All right, so let's start with this first 0 of 2. All right, so let's go f of x. Again, you can change your function notation, g of x, h of x, m of x, q of x, whatever. All right, so the first 0 I want is a 2. In order to get a +2, I need a factor of x minus 2. Now it says multiplicity of 1. So if you want to, you could actually mark that with a power of 1, right? That way just reinforces that multiplicity of 1. And I want a 0 of -4. All right, so if I want a -4, that means my factor needs to be x plus 4. And then to give it multiplicity of 3, I'm going to raise it to the third power, because that means that -4 as a 0 would show up 3 times. All right. Example number 8 here, write an example of a function with zeros of -1, -1, 5, 5, 7, 8, and 12. So I'm not telling you like what the multiplicity is, but you'll notice that some of these zeros are duplicates. So we've got 2 -1s and we have 2 5s. So that means that -1 actually has multiplicity of 2, and 5 has multiplicity of 2, 7, 8, and 12 have multiplicity of 1. So let's go ahead and put this into a function of some kind. So I'll do g of x for this one, just for fun. All right, to make a 0 of -1, I would need x to be x plus 1. But remember, I wanted 2 of these, so let's go ahead and give that a power of 2. Now I need a 5, which means for the factor, I want x minus 5, and I'm going to square that because, again, it had 2 of them in the list. The next value in my list, the next 0 is 7. So I'm going to have x minus 7, but there was only one 7, so I only need one of them. Then I've got x minus 8, again, only one 8, and then x minus 12. That is a nice long function here. So this factor right here would give me -1 and 2 of them. This factor would give me +5, 2 of them. This factor would give me +7, but only 1. This factor would give me +8, again, 1 of them. And this factor would give me +12, and I want 1 of them. All right, so this nasty, fun-looking function right here is the example 8. All right, I think there's 2 more here. There are. All right, so problem number 9 is even less specific. So it says, write an example of a quadratic with 2 distinct roots. There should be roots there, each with multiplicity of 1. So 2 distinct roots. Distinct means that they are different. All right. When I look at my students in class, there are 27 distinct students, right? Each one of you is different. So 2 distinct roots, you get to pick what your roots are. I don't care. It doesn't matter. But distinct roots means they just have to be different, and each with multiplicity of 1. So let's say I'm going to do q of x, q for quadratic. It doesn't matter, all right? 2 distinct roots. Let's say I want my roots to be, and I'm going to make these up, 9 and -13, right? It's just examples. Well, if I want to get the root of 9, that means I would need x minus 9. And if I want the root of -13, I don't know why I'm saying roots. Hold on a second. That should be zeros. Hold on. 2 distinct zeros. There we go. So actually, that's wrong there. I will fix it on your note sheets. All right. 2 distinct zeros, each with multiplicity of 1. I knew this was going too well. Okay. So let's say I want that 0 to be -13. That means the factor would need to be x plus 13. Each with multiplicity of 1. So if you wanted to mark this with a power of 1, you could mark this with a power of 1. I am going to be lazy because you don't have to mark a power of 1. Okay? All right, so write an example of a cubic function with 1 real 0. Sorry about that. Again, I will fix it in your notes. All right, so 1 real 0 with multiplicity of 3. So what 0 do you want? It is totally up to you. Let's say I want my 0 to be 57. All right, it doesn't matter. All right, cubic function, so c of x here. Again, you can call it f of x. You could technically call it y, but because it's in function, I like to keep the function notation. All right, so 1 real 0. So that's going to be, let's say, x minus 57 with multiplicity of 3. All right, let's give it multiplicity of 3. All right, so hopefully you understand kind of how to build some of these functions based off of the zeros that you are given and multiplicity. All right, so as always, if you have any questions or concerns, drop me an email or drop me a message in Canvas, and I hope this has helped explain a couple of things.